Welcome to Prompt Engineering. So, a little bit about me before we get started. I currently work with the New York Times research and development team to integrate state of the art large language models into the Times reporting and products. I also teach Intro to AI courses at the coding school. I got a master's in computer science at Columbia University, and my primary focus is on natural language processing and ethical AI. In the past, I've worked on things like misinformation detection systems with the Columbia Natural Language Processing Lab and research techniques to mitigate bias in word embedding models. Before my work in natural language processing, I was a software engineer on the image search team at Google. Generally, I am interested in how machine learning methods can be leveraged to affect positive change in the world, and especially interested in ensuring that those methods are fair and unbiased. In this talk on prompting generative models, we will explore why prompting is important and look at some examples of how you can prompt models in different ways to aid in tasks in your everyday life. We'll also cover some more advanced prompting techniques like few-shot and prompt chaining. And finally, we will talk about some ways of verifying the outputs you get from these models. What is prompting? Prompting is how you get a generative model to output what you want. So this could be a part of a back and forth conversation with a chatbot or a one-off prompt to get a specific result. And there are so many ways you can tweak or construct your prompt to subtly or not so subtly influence the model's output. So like looking at this example, we've told it what to do, but we've also told it how to do it, right? Which really materially changes the answer here. So why are prompts important? If we're thinking about the entire model, how it works, right? There's all of this complicated stuff going on behind the scenes, stuff that we don't need to worry about when we're just trying to use the model, but that really dramatically influences the quality of the model, what it outputs, how it works, right? Like the way the model is built and what it's trained on, all of this. However, many times, in many situations, the prompt is almost just as important as all of this stuff under the hood. So there are scenarios in which, there are tasks where it doesn't really matter what you say. The model will knows what you know what you want, like really simple tasks, like proofread this email or something. Maybe even that task you can get a little more specific. But there are some examples where you don't really need to think about your prompt. But then there are some other tasks where prompting and how you prompt a model is sort of the be all and end all of getting what you want out of the model. Because prompting can be nuanced, it can be hard to get what you want out of the model, and it's more of an art than a science. There's no hard rules, right, about do this and the model will do this. We've learned that's not how AI works. That's not how generative models work, right? So because this is sort of a kind of it's a nuanced field, it's a subtle field, it's something where it's kind of constantly changing, you can't really pin it down. It's actually acquired the name prompt engineering or prompt designing, where it might take you minutes or hours or days even to get the perfect prompt that gets just what you want out of the model. And it's sort of like a skill, right? Like a skill you can learn. And it can be such a hard or skill-based task that there are even roles for prompt engineers now. So there are even these companies that work either with AI data or just companies that are using AI that want prompt engineers or prompt designers. So there's literally many, many job openings for prompt engineers. Okay, so let's get you all up to speed on prompting and make prompt engineers out of you all. Let's talk about some basic prompt strategies first. So there's a couple things we want to keep in mind when we're prompting, that no matter what kind of prompt we're doing, no matter what kind of model we're prompting, we want to make sure that we're being very clear in what we're saying, that we're not being ambiguous or vague, that we're including the relevant context that the model might need, right? The model can't read your mind. And we're telling it what format we want the output in, whether that's the style we want it to respond in or literally what we want, the output to actually look like. So let's talk a little bit about prompting examples. Okay, so let's talk a little bit about what you can do with generative models. Let's look at some examples of prompts. So something you can do, you can create content, right? You can ask it to generate 5 blog post ideas on the future of AI. You can ask it to create content wholesale, just giving it the theme. You can ask it to translate text, translate this to Spanish at a second grade reading level, right? So it can translate, but it can also translate it in a specific way. Turn this image into a pencil style sketch. So you could upload an image and it will recreate the image, right? Not sure why you'd want to do that, but you can do it. You can ask it to describe an image. So like you upload an image and describe the objects and the colors in this image, right? And it'll give you like a breakdown of everything that's in the image. You can kind of read the image. Create a visual diagram to outline these steps. Let's say you have, some text and you want it to create a diagram about it. It can read the text and create the diagram, right? Proofread this email to find any mistakes. Summarize the key findings in this research paper. So you can kind of give it a lot of text and then ask it to summarize it, right? Many, many, many other things. Here are some other examples. Rewrite this paragraph in APA style, add subtitles to this video, rewrite this technical document for a beginner audience, turn these notes into a podcast script, recreate this photo in the style of Monet, remove the background objects from this photo. So all that to say, there's a lot you can do with generative models. So we've covered some kind of crazy things you can do with prompting. Let's take a look at this one. So let's say we have an article that is pretty long, but we're interested in it, or we need to know for some reason. We can ask whatever your chatbot of choice is to summarize it. So summarize this article. A lot of them can plug into Google search now, so you can just paste a link. And this is an article on someone who loves generative AI, but doesn't like the companies creating it. And so this is like an overview of what this person is talking about in this article. And then let's say you're like, okay, cool, but I know that she ranks these companies by like best to worst. And you didn't talk about that. So now I'm asking, give me the rankings of these firms. So you can kind of treat it as like a living document. You can talk about the article, about the aspects that interest you, about what you need to know more about. And then I'm like, okay, I'm confused. Like, why did she say that OpenAI is worse than Gemini? That wasn't really clear from the bullets that I got. And so we can ask questions about it like that. So as always, you need to keep in mind that we are not positive. We're not sure that any of this is accurate, right? We are like maybe 98% sure, we're pretty sure that this is all accurate from the article, but the model could be missing some things that are important. It could be hallucinating some things. So I'm showing you, I would highlight here, I would, actually go to the, webpage of this article and verify some of the things that I got out of this. So like, okay, cool. So it says like, maybe the most important thing I got out of this is why this person says that OpenAI is a worse company than Google or whatever. And let me verify that. Like, let me make sure that's actually what that article says, or if I need to pull quotes from it or something like that. You will always want to verify, especially like verify even more the more important this knowledge is to you. Like if you're telling other people this, if you're putting it in a presentation or anything like that. So I just want to make that disclaimer, but this can make this much easier than you having to read the whole article yourself. You can get to the points that you care about or just get like a quick summary. So I spend a lot of my time coding and also using Excel sheets. So I won't show a coding example, but I do use these models a lot to help me write scripts and things like that. But let's look at an example of when I'm not really sure exactly what function to use in like a Google Sheet or something like that. I will use these models a lot for help with that. So let's say like I forgot or never knew what the formula is to see if some value in a cell appears in another column in Google Sheets. So I can just, however that makes sense for me to write, I can ask model. We're looking at Claude now, and it will give lots of different ways of doing that. So you can kind of just, take it, copy paste, fit it in. Sometimes, a lot of times this won't work, and I'll have to say like, oh, this didn't work, or like this happened or something. And it will say like, oh, like in this version of Google Sheets or whatever. And, sometimes it doesn't work the best, but when it does work, it's really awesome and really fast. And when you feel great when you can just plug it in and it works. And it's, for me, a little bit quicker than a Google search. I could find the same information on a Google search, but I might have to dig a little bit more to find like the specific use case that for my needs, right? There's a lot of examples out there that might be like a little bit different than what I'm looking for. So here's an example where I'm using this for help in my everyday non-work life. So I recently have decided that I want to get a standing desk, but I have some specifications for that desk that I need. So rather than spending a bunch of time looking at different desks and trying to look at the specifications, which I probably will end up doing anyway, I started here. So I want a standing desk, but I need it to go down to like 25 inches because I'm not that tall, and a lot of standing desks are built for taller people and don't go down low enough for me. I also am trying to fit it into like a built-in bookcase, so I need it to be no more than 23 inches. I forgot width and depth. I confused width and depth. And so I realized that here, saying like that it was like 23 inches wide or narrower, but then it was talking about 24-inch depth. And I was like, oh yeah. I mean 23-inch depth. And then I also realized I didn't put in the length. So rather than needing to start like a search over again, you can just kind of continue on and say like, oh no, I'm kind of updating my specifications here. Generally, I don't read all of this. There's a lot of text. I'll just look at the like bullet points that it outputs. And so I'm like, okay, it gave me some options. It told me sort of like why those fit into what I want. But now maybe I want to see a table of the pros and cons. And I also care about price, right? And I also want to go to the site where I can buy the desk. So I'm asking it to create a table that has all the information, the depth, the width, the minimum height. Again, we're not sure that this is correct, but it's a good place to start. If I click on one of those links and the height's not correct, no biggie, right? If it's missing some, maybe that is kind of a big deal to me. Like maybe I am someone who wants to look at all options possible before I make a decision, which I am. So after this is going to be my place to start. And after this, I'm going to do a Google search where I look at some of these things and then I look at like comparisons between them, maybe on other sites and things like that. But this was a great place for me to start rather than just being overwhelmed with all of the possibilities. And if you're someone who doesn't need to look at all of the options, or it's a purchase that is, not as important to you, or something like that, this could be enough for you. So yeah, I think this is really helpful in a lot of things for work life, but it's also really helpful when you're trying to organize or find information on things for the rest of your life too. Here, I just wanted to give an example of image generation because this is something that I do a lot when I create slide decks. So like this slide deck has images that are generated from prompts, right? And other slide decks that I use for teaching, I create images using prompts. So this is an example for one of my other courses, a prompt I used to get this image that I've used in a slide deck. So if you're someone who makes a lot of slide decks and you need specific images, this can be really helpful as well, being able to create those specific images that you need. So let's talk about how we get the model to do what we want it to do. There's a few prompting techniques that have interesting names that we're going to go over. So one is zero-shot prompting, then we have few-shot prompting, chain of thought prompting, prompt chaining, which is different from chain of thought prompting, and reverse prompting. So let's start with zero-shot prompting. Let's say that we have this text. This is just a Wikipedia article, but let's just say that we have this text and we want the model to summarize it or trim it to be more succinct. We want, the essence of the text, but much, much more compressed. So let's say we ask it, trim this text to be more succinct, right? That's our prompt. And then we input the text and then we'll get out an answer. Here's a more succinct version of your text while preserving key details. It added in the part about preserving key details. I didn't say that, but it decided that's what we wanted, right? So it became a little bit shorter, but let's say we wanted it a lot shorter. Let's say what we meant was like 1 or 2 sentences, right? Or 3 sentences or a paragraph or something. With zero-shot prompting, well, we could say that. We could say like maybe using only 3 sentences or something like that. But with zero-shot prompting, it's basically you give the prompt and you give the text you want it to do something with, or you just give it the prompt like, create an email that asks these questions or something like that. And that's zero-shot prompting. Few-shot prompting, on the other hand, is the same thing, except you're giving it examples. You're giving it examples of input and output. So you give it the prompt, right? You want it to trim text, right? So in this case, the beginning of the prompt is, you're someone, you trim text to be more succinct, right? Like that's your task. This is what you do. Then you give it examples. So you would say, here are the examples. This is the input text, right? We say examples, then we say input. We have this article. And then we say, here's the output from that article, right? Like, here's what we would want that to look like. we already have this article trimmed. Someone did it, right? We know we want that to be what the output is for this article. Again, give it another example. Input. This is what, would be input, and this is what we would want as an output. And this is all in the same prompt. I just couldn't fit it all in one screen. It would be too tiny, but it's all in the same prompt, right? And then you say, okay, now trim this text. And this is our original article from the zero-shot prompt. And we wanted to trim this text to be more succinct. But as you've seen in our examples here, we've shown that we want the output to be really, really short, right? Like these are one sentence outputs. So, okay, now trim this text. What you get is a shorter version of what we got before, right? So zero-shot prompting, we got this version up top. And with few-shot prompting, not telling it to make it any shorter, right? We got this shorter example because we gave examples where the outputs were shorter. So that's few-shot prompting. So we can compare them. We have zero-shot where we explain the task, we give the context or the input for the task, and then we get the output. With few-shot prompting, we explain the task, and then we give example input, example output, example input, example output, so on, however many you want to give, usually not more than just a few. You can give like one or two. You could give up to like, I think in some examples I've used like 10 plus, but you give, however many examples you want, and then you give your task input that you don't have the output for yet, right? Let's talk about chain of thought prompting. So we have zero-shot, we have few-shot. Now let's talk about chain of thought. So years ago, when these sort of like language models were not as good, we might not need this chain of thought prompting as much now because they kind of tend to do this behind the scenes. But a few years ago, when the models weren't as good, there was studies that found that just asking for answers to what the model would consider a complicated question sometimes got the wrong answer. So if you see on the left, this standard prompting thing, this is an example of few-shot prompting, right? It's giving one example. Here's a question, here's an answer, now answer this question, right? It gets it wrong. These models are notoriously bad at math. They're getting a little bit better, but they're still not great. A couple years ago, they were even worse. So these sort of like word problem type questions were really big pitfalls for the model. So with chain of thought prompting, you give it a question and then you give it an example showing, here's what I want you to do, right? Like I want you to think step by step. This is how you're going to answer it. Roger started with 5 balls, 2 cans of 3 tennis balls, blah, 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 blah. Think through it. What we would do in our brain or what we would say out loud as we're thinking through the problem and then get to the answer. So it's sort of like show your work, right? It's like, on a math test, don't just write the answer, show your work. That actually made the models more likely to output the correct answer to these types of questions. We might say that there's not correct answers to all questions. A lot of the questions or a lot of the prompts we're giving the model don't have like concrete correct answers like these math problems, but it still generates better answers in a lot of cases where it's more thought through. Some of the pitfalls where it might have, gotten tripped up aren't there anymore because it thought through those pitfalls. Again, this is not as necessary as it used to be, but it's still something to keep in mind as like, if you're not getting what you want out of the prompt, this is a technique you can use. So we have our zero-shot, we have our few-shot, where we have, our example input, example output, and then chain of thought, where we have our example input, and then we example step 1, example step 2, right? However many steps we want it to think through, and then we have our task input. Okay, and then we have our task input. Okay. Now we're going to talk about prompt chaining, which is different from chain of thought. And this is very applicable now. So prompt chaining is basically, instead of asking the model to do one big task that is sort of complicated, has a lot of moving parts all at once, we break that into smaller prompts. And we ask it to do one part of the task first, get the output, then use that output as input for the next ask, and so on and so on. So let's look at an example. We're trying to create a prompt for a restaurant assistant. So this assistant is supposed to assist with like messages from customers. Maybe the customer wants to order food or make a reservation or ask some other question, right? So at the beginning, we're telling it, your task is to determine the user's intent, whether they're ordering food, making a reservation, or some other inquiry. Based on that intent, follow the specific flow of tasks below. And then we say like, okay, if it's ordering food, do this. If it's making a reservation, do this, right? That's a lot to put in one prompt. That would be, let's say that you are, trying to train a new employee. If you're just yelling all this at them, like, okay, they're going to do this, this, and this, and then if they do this, right? We don't expect them to get it on the first run either. Like this is a lot of information. This is a lot to deal with at one time. So instead of just putting this all in one prompt and being like, here's all your information, go, right? We can break it into different tasks. So we can break it into steps. We might have our intent classification prompt. Okay, so now all you're doing is deciding whether the user is making a reservation, ordering food, or some other inquiry, right? So then we get this output. The intent is a make a reservation. We don't care, the model doesn't care what we want to do with that. All it says is this user is trying to make a reservation. Then we can take that output and put it into our second step, right? So, okay, the model said the intent is make a reservation. Now that we know that, let's give our model the reservation prompt instead of all the other information it didn't need about ordering food, right? Now we want you to help this person make a reservation now that we know that's what they're doing, right? And so we give it the previous user message. We give it like the fact that they're, trying to make a reservation, and this is the information, like we want a reservation at 7 p.m. or whatever. And you can do that, for you can chain as many different prompts as you want together. And this is something that I use a lot in my work. This is something that I think a lot of people use nowadays. It's also easier to evaluate when you do prompt chaining like this. So you can evaluate, like, let's say you have everything in one prompt and you realize like, wow, it's really getting it wrong like a lot of the time. But you don't really know what's going wrong. Like what step of the process is it getting wrong? Where is it getting tripped up? If you do prompt chaining like this, you can be like, oh, okay, like actually it gets task 1 right most of the time. Like it usually knows what the user intent is, whether it's make a reservation or order food or whatever. It gets tripped up after that. Like, okay, cool. We don't have to focus on task 1. It knows what it's doing. Let's focus on the prompt for task 2 or like reevaluating the task for that or, whatever needs to happen. So there is another technique that some people call reverse prompting, where you basically say to the model, here is like the task I want to do, here's the output I want to get. If you have some output examples like you would use in your QShot or something like that, what is a good prompt to get me to this point? And so sometimes you can ask the model for the prompt that you're going to use on it, right? Like be like, what prompt would get me this output in this scenario? So that's another technique you can use, you can try as well. Let's talk about how to refine your prompts. Let's say, you're using some of the prompting techniques, but you're still not getting what you want, right? So let's talk about some like more specific, deeper techniques that you can use. All right, let's say that we have this task. We want model to summarize this piece of text, right? What if this isn't exactly what we want though? So let's say we want it to be, shorter than this, right? So we want it to be summarized in 3 to 5 sentences. We can say that. Maybe we want to make sure that it's a neutral professional tone because we're going to include it in a business newsletter, right? For our investors or whatever. So you can tell it the style you want it to respond in, right? This is something that's really key, providing context. So where is this coming from? This is part of a weekly trend report on energy investments, right? This thing that we've pulled out. We can also give it last week's report and say, we want to point out how this week's insights align with or differ from last week's. Like we're giving it more pointers on what we want the summary to look like, right? And then this one's also really important, outlining the format you want for the response. We're telling it to structure your response. Summary, your summary here. Here are the key similarities. Here are the key differences from last week's report, right? So suddenly we have, instead of just like summarize this, right? We've told it more about what's in our head, what we want this to look like, right? Like we know this was last week's report. We know we want it only in 3 to 5 sentences. We know we want it in a neutral professional tone, and we know we want it to look like this, but we're telling the model that now. So it's a little bit more work, but you're going to get out something that you want, right? So that's why like prompt engineering can be work, because you do have to do some thought on your own. You need to include a lot of details in your prompt sometimes to get what you want. Prompt engineering or prompt design is an iterative process. So you're going to start simple. You might start with summarize this and see what it gives you, right? Then you're going to check your output, and then you're going to refine it, and then you'll repeat and keep refining. So this could be a actual process that you go through, right? You could say, summarize this piece of text. Oh wait, actually, no, I want it in 3 to 5 sentences. Oh wait, actually, this is not the correct tone. Actually, I think I actually want it to, talk about the differences between last week. So now I have to give it last week's report, right? Oh, it's not giving me the structure I want. So you might go through this process, right? And throughout this, you should understand which parts of your prompt are most influential on the results. So maybe a one-word change actually makes a world of difference. For instance, maybe calling this, key points, right, instead of summary in the response structure that you want, makes a huge difference in the quality of your output. Maybe kind of giving it that hint, like, actually, this is key points rather than a summary, changes it to be more like what you want or less like what you want, right? So the wording that you choose matters. So let's look at an example of when wording can really change your output. So here's a prompt. Describe the process of photosynthesis. Okay, so we get this output that has like these steps, right? Like here's a step-by-step breakdown. We have this like actual includes like the chemical equation, right? So it's like a pretty scientific response. Okay, we change our prompt very slightly. Describe the beauty of the process of photosynthesis. So we've added 3 words here, the beauty of the process of photosynthesis. We get a completely different response. It's much more like poetic. There's no steps. There's no scientific breakdown, right? There's no chemical equations. If you read some of this, it's like leaves with their delicate veins and chlorophyll-rich cells, blah, 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 silently harvesting photons from the sun. Whereas this is just like chlorophyll absorbs sunlight, right? So a very, very small change results in a completely different output here. So you can kind of extrapolate this to maybe very small changes in your wording that you are not aware of or that you wouldn't think would cause differences in your output, right? So be really careful about like ambiguous wording, overly broad or vague requests, like these hidden assumptions that you have in your prompts. Like for example, like asking, what's wrong with this marketing campaign versus analyze the results of this marketing campaign could get you 2 very different responses, right? Okay, let's talk about another prompting technique that's slightly different from just modifying your prompt. So a lot of you may have heard of RAG, or Retrieval Augmented Generation. We're going to briefly go over what this is. So in Retrieval Augmented Generation, you still have your query or your prompt or whatever it is you're trying to get out of the model, but you're going to retrieve context for that prompt. So maybe you have hundreds of thousands of pages of documents, and you don't know where a specific like paragraph is in there, right? But you know there's probably something about your request. Let's say you're asking like, summarize like the data in these documents that deal with something to do with temperature or climate or something like that. So you're not going to read 100,000 pages to figure out where that is. But what you can do is if you have a retrieval augmented system or generation system set up where you have this context that is stored in a way in what we call embeddings, which we're not going to really get into exactly what that is because it's way out of the scope of this lesson. But they're stored in a way that these models can easily look up. So you will have your prompt asking for the summary of these like vague terms or whatever. It will find the relevant context that deals with that in your hundreds of thousands of pages. And then along with your original prompt, that context will also be passed to the model. You can pass both your prompt and the context that was retrieved based on your prompt to your generative model. And then you can get a response that is based on that context. So this is used a lot when you have a large amount of potential context for your queries, for your prompts. And you can't, paste the whole thing in. Or even if you could paste the whole thing in, it's way too much for the model to deal with at once. Remember when we talked about like giving the model like a million different tasks and a really, really long prompt kind of creates diminishing returns. It doesn't do as well for you as if you give it like more succinct, here's what I want you to do, or here's the context, and it's not that long, right? So if you can retrieve context that is actually relevant to what you're asking, then you can get a better answer. So far, in all of our examples, we have been kind of talking as if you just prompt the model right, it will give you what you want, right? But that's actually not always the case. So let's go back to some of these ones we looked at earlier, right? So this is one of the examples we gave earlier. Turn this image into a pencil style sketch so you can create an image in a specific style, right? But if you look at this closely, well, it did a really good job of capturing most things in this image. It changed a couple things, right? So if you look at the far left, the little vase on the far left, and how it reconstructed that, the designs are different. Same with the one in the middle, slightly different, right? Same with the one on the right, slightly different. It also, I think, removed a flower on the one on the left. It removed one of the flowers and changed sort of the orientation of them. So maybe all you need, for whatever reason you need a pencil sketch, maybe all you need is basically the same, like if you're glancing at it, it looks the same. But if you need something to be completely accurate, like you need it to reconstruct an image in a completely accurate way, it's probably not going to work very well for you. You could ask it a couple more times. You could say like, oh no, the second face is wrong or whatever. But it might be hard to get it exactly accurate. Let's look at this one. So we ask it to create a visual diagram to outline these steps, right? So we've created this diagram. First glance, wow, cool diagram. It looks like a game card, right? It looks like instructions for a game. Okay, let's look a little closer though. Let's look at like the top right. It says roll 2 dice, but then it says like rove 2 dice, and then what is that picture? And then what's another one? 1.4 shuffle cards on the top left. It says roll turn on the spots, and then has some icons that are maybe supposed to look like dice and then something else. I don't know. There's probably a lot more kind of weird things in here. Any unpurchased property a player declines, like it, some weird grammar or some words that aren't words. You could probably look more closely at this and find a lot more kind of funny either images or language in here that doesn't really make sense, right? So again, first glance, great. Closer look, not great. If you were using this if you want to like print a game card for Monopoly and like distribute it to all of your customers, this wouldn't do, right? These are examples of hallucinations. This example of this slide card and this example of kind of creating things that didn't exist originally, right? And we're going to cover, in the next part of the course, we're going to cover hallucinations and what they are. But basically, it's when models generate inaccurate, irrelevant, or nonsensical responses. Can be in images, can be in text too. Basically, anything generative, any generative model that is creating content is prone to hallucination, to coming up with things that are inaccurate, irrelevant, or nonsensical, right? But what that means for this course is that you need to be really careful when using these models for generation. Sometimes you're asking for something that you can verify on the spot, right? Create an email that covers these points in response to this email, right? For example, you can read the email and be like, cool, that's great, that covers, there's no random words in there, it's not bringing anything weird into it, right? You can look it over, make sure it has what you want, has what you want, and then you can send it. But with other tasks, larger tasks, or tasks where you don't really know the correct answer, right? Like there is no correct answer, or you're asking it to rely on facts, but you don't know the facts, right? You might not know everything it's outputting, whether it's correct or not. That's where things can get tricky. This is another example from earlier when we said you could summarize the key findings in this research paper, right? You give it a paper, summarize this research paper, and then it gives you a little paragraph output, right? But how do you know? Without reading the paper, how do you know that that's right? Maybe it included things that are not supposed to be there. Maybe it missed some key points of the paper. So you're reading this paragraph being like, cool, I understand the paper now, but you missed like a whole key point that if someone was quizzing you on the paper or it was important that you knew this paper, you would have missed, right? You could just read the research paper yourself and come up with a, mental sort of idea of what the summary would be and then see if it matches what you got out. But then what's the point of asking the LM? You just did the task, right? For some tasks, there is no foolproof way to verify the output. So for a lot of the tasks that you're asking of these models, you will never be certain that the AI output is exactly what you want. Doesn't mean you can't use it, right? But you need to be aware of this sort of like margin of error. You need to be aware that wherever you're putting this out, wherever you're using this, there could be false information in there. There could be information that should be in there that isn't, right? There could be weird random drawings on a Monopoly game card that don't exist, that shouldn't exist, right? But let's talk about some of the ways that you can boost your confidence in the output, or at least have some information about like the level of accuracy you might have, or like the level of errors you might expect. So let's talk about three different sort of approaches to verifying your outputs. One is pretty simple, like humans review the output, right? If it's sensitive, if it's something that needs to be right, you should always have a human look it over, like an important email, something that's customer facing, et cetera, right? These should be in front of human eyes. Maybe you can skim it, whatever, but humans should be looking at the output, right? For things that require a right answer, you can have an eval data set that you can check your accuracy and iterate against. If there's no eval data set, like if you don't have like a set of correct answers, right, you can, again, have humans be looking it over. Maybe they don't look over every example. Maybe they're skimming, right? But a large enough chunk has been looked over by humans to be sure, okay, it's all accurate, or we only have like X% error rate or something like that. So what the statistical eval can look like if you do have actual statistical analysis on your outputs. So let's say, again, we're back to like this customer triage example where we are getting messages from customers trying to decide whether they are like what their request is it if it's reservation request or ordering food or some other query, right? So let's say that up until now we have had customer service representatives triaging the emails or the messages or whatever, and so we actually have a database of correct responses, like correct categorizations. So in this sense, in this example, we can have our correct classifications, and then we can ask the model what it would classify this customer message as, and we can see whether it's correct or not. So in this case, we can see like, oh, interesting. Like a lot of times when the correct classification is other query, we're getting it wrong. The model is getting it wrong, right? And so if you have this on a large enough scale, like maybe you have hundreds or thousands of examples of this even, right? You can get a sense like, okay, our model is 96% accurate or something like that. Maybe that's enough. Maybe that's not. Maybe you'll iterate on your prompt until it is 100%. Well, you're probably not going to get 100, but till it's 99% accurate, right? Or until it hits whatever threshold you deem fine. So this is a really, really good way when you have this like kind of large task you're asking of a model, and it's going to be something that is like repeated a lot. It's not just a one-off task, and you have data already that has the correct answers. This is a really, really good way of kind of understanding the output landscape of what you're getting. A third system that you can use, which is sort of a little counterintuitive, a little odd, but people do it. You can use an LLM as judge. LLM is just a large language model. I may have used that acronym in this talk previously. Basically, it's a generative language model. So we're talking about like image models and things like that, but we're also talking about language models. So an LLM is just one of these like generative language models. So this is when you have model scoring models. So we literally use another instance, like another model or another prompt to the same model to score the output from that model. Okay, so first off, this is an example of LLM as judge, but first off, which prompting technique are we using here? So we are giving it the task, right? And we're giving it the output format, and then we give it some example evaluations here. So we're saying like, here's what we want you to do, here's the format we want it to be in, and actually here are some examples of, like what we've already done. Like, okay, like here's the accuracy check, here's like the clarity and conciseness check, here are the scores for these, right? So this is few shot prompting, right? Because we're giving it examples. That's just a little bit of an aside, kind of a callback. Okay, let's talk though about this LLM as judge. We're providing the context, we're ensuring the right level of specificity here, and then we're outlining the format you want for the response. So we've checked all our boxes here. We've done all of the things that we talked about earlier that we want to do. So what we're doing here is we're asking the model to judge the output from the model. So it could be the same model, it could be a different model. Let's say we get this output and we say, okay, I want you to judge it and say like, does this summary capture the main argument? Give it a score. Is the summary accurate? Give it a score. Is it concise and clear? Give it a score, right? And so again, obviously, this is not perfect. You're using the same imperfect system to verify its own outputs, right? So like inherently, anyone can see, oh, this might not work, right? This might not go the way you want it to. However, it can help. Like it can catch errors. It can give you a little bit more confidence, right? So you're asking the model to sort of like say like, this came from somewhere else. Now judge it, right? How good is this? And if it's a good model, it might be able to give you some good feedback. Obviously, if something is really important, or just in general, you should probably be having some human in the loop or some type of statistical eval as well. But this can be sort of an additional tool in your toolkit as well. Okay, what's the bottom line about verifying the outputs? We want to verify information if high accuracy is required. And we also want to be transparent when something is AI generated. So maybe it gets it wrong, maybe it hallucinates, right? But if we say this is an AI generated image or this is an AI generated piece of text, we're upfront about that. So people who are using it, who are interacting with it, will be able to kind of see, oh, this is AI generated, kind of decide for themselves how much confidence they want to give it, right? It's sort of a responsible way of both kind of getting yourself off the hook a little bit, but also being clear. And you're not saying like, oh, this is fact, or this is like, this is perfectly executed because I did it myself, right? You're being clear that you used a tool to do this and it's an imperfect tool. Okay, so this is the end of our sort of little lesson on prompting. I hope you learned at least something about how to get what you want out of a model and how to tweak your prompt and change your prompt and refine your prompt and evaluate your prompts, evaluate your results to get the best result possible you can out of your model. So let's talk a little bit about video prompting. There are a lot of new tools out there to use to create short videos, short AI generated videos. This is a newer technology, a newer aspect of these generative models. So there's still some of this sort of like weirdness that came from generated images that have sort of been solved now. It still exists in a lot of this video generation, but it has also come a long way where you can get videos that are pretty hard to distinguish from real life videos. So some of these tools are Google Veo, OpenAI Sora, there's another company called Runway, InVideo AI, and dozens more that will do this. And they allow you to do a lot of different things. Maybe choose the type of video that you want to make. You can create a video from images in a lot of cases. You could upload an image that will be turned into sort of like a short moving video. Sometimes they allow you to manipulate the video after creation, just like any other like video editing software. So you can use a text prompt, just like other generative models. Some resources allow you to like use an article URL. So it will sort of like take the article and create a script and then create the video. So there's lots of different like ways you can start prompting these models and steps you can take in the prompting process. So let's look at an example here. This is one that I just prompted with the short prompt street interview. And this is the video that was created. So pretty good. It's like a little weird, a little off in some ways, but if you were just glancing at it, you would be like, yeah, that's a real video that someone took, right? Which is, good and bad in some ways. We can go into all of the reasons why that can be scary as well. You can also then be like, okay, that wasn't exactly what I wanted. I want it to be winter. So you can say, make it winter. And one thing that I noticed here is that even though I asked it to update the specific video, it did make it winter, but it changed. It kept a little, like the background is a similar vibe. It's not exactly the same, but it changed the characters in the video. So you got a little bit of a different video than you started with. So again, this technology is really making strides. It's not quite there yet, but for some purposes, it's definitely good enough. So we have covered why prompting is important and the different use cases for model prompting, as well as different prompting techniques. We've also talked about ways that you can verify the outputs that you get from these models, and also talked about how we can never be 100% certain about the outputs we are getting just due to the nature of how these models work.